Hello, families. So this is a brief overview of what we did today. We're simply trying to identify dividing fractions by fractions using a visual model. So we're just now starting the process of understanding why dividing by fractions works. Students were introduced to this concept in the 5th grade. However, now in the 6th grade, they're going to be expected to master this method. First, though, let's use a visual model to figure out why the method works. The easiest one to use is 1/2 divided by 1/4. So if we had the problem 1/2 divided by 1/4, I could represent this visually by presenting 1/2 of a circle and then asking you if I were to divide that up into equal pieces, and those pieces were exactly 1/4 in size, and it's 1/4 of a whole, not 1/4 of the half. So 1/4 of the whole, how many times would I be able to divide this half into fourths? And this one's pretty easy to see. We can see that I can fit in 1/4 here. That is 1/4. And I can fit in a 1/4 here. Oops, excuse me. I don't know why I did that. 1/4 here. So to answer the question, how many times can 1/4 fit into 1/2? Or how many times can I divide 1/2 into pieces that are the size 1/4? My answer would be 2. And we say, okay, how am I going to mathematically get from 1/2 divided by 1/4 to the answer of 2? Well, students learned in 5th grade that division of fractions is going to require us to go ahead and change our operation. So we keep the first fraction the same. We're still trying to figure out how many times 1/4 is going to go into 1/2, except instead of division, we are going to change our operation to multiplication, and then we're going to flip our second fraction. So instead of 1/4, we're going to multiply 4/1. And what we learn in algebra and later in 7th and 8th grade is that dividing by a number is the same as multiplying by its inverse. And students get introduced to that concept. It sounds complicated, but it's not. If I want to divide by 10, I can also multiply by 1/10. Or I can multiply by 0.1, which is also 1/10. So I can multiply by a 10th, or I can divide by 10. And that's the same thing. So an inverse operation for a number that is the inverse of itself. 10 is the inverse of 1/10. 1/10 is the inverse of 10. We just change the operation and we invert the number we're working with. And if we multiply straight across here, students are very comfortable with this process. 1 times 4 is 4. 2 times 1 is 2. We go ahead and reduce that fraction. Simplify that fraction. 4 divided by 2 is 2. Students are comfortable with this. So we just need to understand that when we start with a division problem, we are going to flip and multiply. You might have heard that. Students may have heard keep the first fraction, change your operation, flip the second fraction. That might be something they're familiar with. But either way, we need to know that we change our operation from division to multiplication, and we flip our fraction, the second one, from 1/4 to 4/1. Now, if we change the order of this problem, we can still use the same model, but it becomes a little more complicated to see. So if I'm going to take 1/4 and I'm going to divide it and see how many times can 1/2 be divided into a 4th. And before we actually did the drawing model, I asked students if I had a quarter gallon, of a container. And I wanted to see how many times I could fit in a half gallon of milk into that quarter gallon container. we know we're going to get less than 1. As I start pouring this milk from my half-gallon container into my quarter-gallon, from my half-gallon container into my quarter-gallon container, as I'm pouring in the fluid, I know for sure I'm going to run out of room. So I'm not going to be able to fit in this half-gallon container into this quarter-gallon. I'm not going to be able to fit it in one time. It's going to be less than 1. At some point, I'm going to have to stop pouring if I don't want to make a mess. So our answer should be less than 1. Okay, so with that in mind, let's go back to our pie drawing. And I'm going to take 1/4, and I need to see how many times I can fit 1/2 into that quarter. Well, we know it's not even once. So I'm going to come here. Oops, blue is not great. Let's do light blue. And even that's not great. Let's do yellow. This is 1/2. And how many times I can fit that 1/2 into that quarter? Well, I can't even fit it a whole time. So I'm going to have to start peeling off my half. I can't fit this much in. I can't fit this much in. The only amount of my half that I can fit in is this part. Well, if I'm looking at my half, how much of it fit into my quarter? Well, only 1/2 of my half did. So only half of my half could fit into a quarter. So the answer should be 1/2. And well, let's see if we use our algorithm and we come up with the answer 1/2. Hopefully we can see that here, that only half of my half is going to fit into that quarter. I can't fit all of my half into it. I can only fit half of it. So let's work through our problem. First fraction stays the same. Change our operation to multiplication. Flip the second fraction. Multiply straight across. Multiply straight across. Reduce our fraction. We get the answer 1/2. So visually, we can see that this method of keep, change, flip, flip and multiply, whatever it is that your student uses to remember the process, isn't coming out of nowhere. It represents an actual physical model of how we would divide fractions by fractions. So that's what we learned in class. Use the timestamps to get to the homework. Homework is here. So this is a brand new concept. So I didn't give your students homework on dividing fractions. Instead, it's multiplying fractions. This is what we've been doing up until this point. Students here should just multiply straight across. We're recognizing that the word of means multiplication. 1 times 2 is 2. 3 times 3 is 9. Oops, 2. So our answer right here is 2/9. That cannot be reduced. 5/6 of 3. We need to change that whole number into a fraction, which is 3/1. Multiply straight across, that is 15/6. We're going to go ahead and simplify this in proper fraction. 6 goes into 15 twice, with 3 left over. 3/6 can be further reduced to 1/2. So 2.5 times. And if we multiplied 5/6 times 2.5, we would get 3. Let's go ahead and take a look at 2/3 of 5/6. This one, we're just going to multiply straight across. 2 times 5 is 10. 3 times 6 is 18. We realize that 10 and 18 have a common factor of 2. So we're going to reduce by 2. This is 5. So that's not a great 5. 5. 18 reduces by 2. That's 9. So 5/9 is the answer there. And then finally, 2/5 of 5/8. Now, some parents, you might recognize, hey, wait a minute, can't I just cross reduce? I recognize this 5 and this 5, and can't I just cancel them out? Absolutely, you can do that, but let's go ahead and wait till algebra before we start using that as a regular process. And let's just continue using the algorithm the way we have it and multiply straight across. 2 times 5 is 10. 5 times 8 is 40. 10 is a common factor, of both 10 and 40. So we're going to reduce by 10. That gives us 1/4. This is your students' homework for the night. That's all I assigned, just 4 problems. I'm hoping that students didn't struggle with that at all. That's going to end up on our next quiz. Thank you very much for taking the time to watch the video, and have a great evening.